Hey, what is up everyone? Welcome back to another video. In this video, we're going to do a little bit of building. So we're not really doing hacking. It's not necessarily blue team, but we're going to build a web app together using Terraform in AWS. We're going to try to spin it up in Terraform, spin up this web app. I think you might even be able to visit it. I'll have to check it out to see how the lab works, but I'm excited to do that. And the reason I want to do this lab is, well, really for a few reasons. I'm going to showcase the Cybr platform. I've done a few of their labs on stream and some standalone videos about them, but I love Cybr, and the reason I haven't showcased a lot of the hands-on labs is because I've been doing their courses. So I finished one course on AWS security. I'm going through a blue team course right now on incident response. A lot of fun, learning a lot in the process, but Christoph and his team over at Cybr have been killing it on the releases. So I wanted to just showcase some of these new labs that they have released, and also I suck at Terraform. Now Terraform is infrastructure as code. I have used it a little bit, so I created a CloudGoat scenario. You can actually see it over on CloudGoat if you look at the PRs that teaches AWS pen testing. It's not like officially released yet. Instead, we're kind of holding it back. When we do the official release, there'll be a blog post on the Rhino blog. I have a Try Hack Me room that goes with it, an official video walkthrough with it. But when I was making that, I have to use Terraform, and I realized how much I suck at Terraform. So then, when I saw that Christoph released a Terraform lab that allows us to spin up an S3, a web server from an S3 bucket, I thought, let's do it. Let's see if we can learn about this, and we will dive into it. Let me go ahead and introduce you guys to Cybr. If you've never heard of it before, here is Cybr. So it's CYBR. Once again, cybr.com. I'll just drop the link in chat. This should go to all of the platforms that are hanging out with us. But it's Cybr.com, and the lab that we are going to do today is completely free. So if you're watching this after the fact on YouTube, go ahead and make a free account on Cybr, and you can follow along. It's helpful to watch someone do a lab, but it's way more helpful if you do the lab alongside of them, and you learn more in the process by having your hands on the keyboard. So once again, this is a completely free lab. You don't need a sub. None of that is needed. But I will just say, if you do get a sub, it is well worth it. If we go over to pricing, you can see that right now, 129 years for the entire year, or just $10 a month, you get full access to every lab on Cybr, as well as every single course. So let me just show this off real quick before we dive into stuff. If we go to all courses right now, I will show you guys the course I'm working through. So I finished two courses. I finished the Beginner's Guide to AWS CloudTrail for Security. I also finished another course, Introduction to AWS Security, and this is the course I'm going through right now. But with that $10 sub, you get access to all of these courses, and these aren't just like cheap courses thrown together. I'll give you a quick glimpse of just one of these lessons. So I actually created an entire lab on my own AWS Sandbox account for this. The first thing we did is we did a breach, right? Like we breached our own AWS account, and then we responded to it. And now I'm going through a crypto mining one where like we got breached with a crypto miner, and we're going through it. But just to show you like the quality of this, each one of these modules has a full detailed video that goes alongside of it. Super high quality, really good audio from it. I don't know if you can hear it. I don't think it's probably coming through my VM, but it's really well done by Christoph as he works through this, as well as full text of everything that we're going through. So these courses really are amazing. I have learned a lot as I've been going through it. And with that premium sub to Cybr, you get access to all of these courses. You can also just pay for them if you want, standalone price. But I think the sub is worth it. You get access to all the courses. It's only about $10 a month, and you get access to all of the labs. But today, we're just going to showcase a little bit of this with a completely free lab. Now, there's a few different ways you can get to the labs. If you go to the Learn tab, once you make your account, you can click Hands-On. But what I like is this Learning Paths Notion sheet. So if we pull up this Notion sheet, we can see all the different learning paths in Cybr, depending on what we want to do. So we have role-based learning paths for blue teaming and red teaming, topic-based learning paths, so depending on what you want to learn. What I'm going to do is if we scroll all the way down to the bottom, we have the hands-on learning paths. A question we'll sometimes get is, which of our hands-on labs should I start with? Here's a breakdown of our hands-on labs by level of difficulty and category, and we're just going to start with this top one, create a static S3 website using Terraform. Now, I've already defined Terraform. Even if you're brand new to AWS, you should be able to follow along. Terraform is infrastructure as code. It allows you to use code in order to spin up resources in various cloud environments. And in S3 is an S3 bucket. I always try to think of it like an FTP server, but for the cloud. It's a server that can host static files on it, and you can also host a static web server on it, which is what we are going to do. So you can pull up the lab there. And here is our lab right here. I'm gonna go ahead and click Start Lab. I didn't do it ahead of time because it only gives you a time limit of 60 minutes for the free lab, so didn't want to run out of time. But we'll go through this entire thing together. We're gonna learn how to create and configure a static S3 website using only Terraform. This lab does not grant access to the AWS console, encouraging both least privilege and using infrastructure as code to manage cloud infrastructure instead of ClickOps. While it loads, we'll go through some of the introduction. We will be learning about HashiCorp Terraform, an infrastructure as code language that enables us to build and maintain infrastructure via code. Now we're going to set up our development environment. A few things that we need. I already have the AWS CLI installed, but I have a whole video that goes through working with the AWS CLI, but we do need to install Terraform. I don't think I have it installed on this VM because it's a pretty new VM, so we can go ahead and do that together. There's a few different ways that we can do this, but probably the easiest is just the pre-compiled binary. So let's go over to appropriate package and let's see if we can find what we need. So here we go. We can do our pre-compiled binary right here, AMD64. Let's go ahead and download that. And then we will open up our terminal. We'll CD over to downloads. We'll do ls, and here is the Terraform right there. So we'll do unzip Terraform. And there it is right there. If we run it, we should be able to get output on it, which we do. And now we just want to put it in our path. If you're new to Linux, path is just where it's looking to execute these binaries. If we echo out our path, we can see what our path is. And all we need to do is move Terraform into our path. So let's go ahead and do this. We'll do sudo move Terraform, and we'll just do user local bin like so. Type in your password. And now if I'm not in that directory, it should still work, and it does. We should be good to go. We will go ahead and make a directory for Cybr, and we'll jump over to Cybr, and I'll make a directory, and we'll just call it Terraform S3. I'll know what that is, and there we go. We are in our directory. What else do we need to install? We can also install Visual Studio Code, which I also don't have on this VM, since it is a brand new VM. So I'll show you how to do that as well in Kali. If we just go to the install link, we will download the .debian file. Should not take too long, and we'll go ahead and get that installed, and then we should be able to start knocking out this lab. CD to home downloads. Is it done yet? And it is right there. So there's code. We can install this super easily with dpkg. Actually, we're not going to sudo dpkg/i, and then not Cato code rather. There we go. And we'll allow that to do its thing. We'll change this over to terminal, and that is done. We should be able to see Visual Studio Code is there. So we are good to go. We have installed all the dependencies, and we can dive into the lab. We have our credentials right there. Now, if you're new to AWS, the access key ID is sort of like the username. This in of itself is not super sensitive, but the secret is because it gives someone access to your AWS account. But with this, on the command line, we can authenticate as this user. Before I get ahead of myself, let's just go through this entire lab together. The temptation when we do a lab like this is to skim it, but I think it's important to slow down, read the material, and let's understand what we are doing. So what is infrastructure as code? Infrastructure as code enables creating and managing infrastructure like virtual machines, networks, and more using code. So if you want to be a cloud engineer, lean in. This is going to be super helpful. So instead of going to the AWS console and manually creating dozens of resources, we write the code to do this. Right? It now goes through the same software dev lifecycle as any application code should. It means we can do version control, automate deployments and updates, identify and remediate security issues prior to deployment, and more. Terraform is arguably the most popular IAC, or infrastructure as code tool, is open source and supports thousands of industry solutions like AWS, Azure, Kubernetes, Proxmox, Okta, and more. Several other solutions do exist, however, including AWS CloudFormation, Pulumi, and OpenTofu. So Terraform providers. To build infrastructure on AWS or other solutions, Terraform relies on providers. These are essentially plugins that translate Terraform code into API calls for a service. So all you have to worry about is writing Terraform code, and the provider will handle the rest. So we can look at the providers here. We can just pull it up. And you can see some of the big ones here, but just a bunch of different providers that we could work with. Looking at the AWS provider, we can see a few things. So we can go ahead and pull that up. AWS. Lifecycle managed AWS resources, including EC2, Lambda, EKS, ECS, VPC, S3, RDS, DynamoDB, and more. This is maintained internally by the HashiCorp AWS provider team. So official, provided by HashiCorp, most trusted and up to date. It's the version of the provider source code. In order to get to the source code, since it is open source, we can see it right there. And documentation on various AWS resources that can be created. So let's go ahead and configure our credentials. We'll scroll back up here, and what we need to do is copy our access key ID just by clicking in there, and we will do AWS configure, pass it a profile, we'll call it lab, and drop in our access key ID. Now we need to grab our secret key, so we'll grab it there and drop in our secret key. I don't know if region matters. I'm guessing US East 1 will be sufficient. And yeah, we should be fine doing US East 1. We can do JSON, and there we go. Now, to make sure it worked in Linux, you can do who am I, but AWS likes to make it more confusing, so we have to do AWS STS get caller identity. You can see it there, and we'll just do profile lab, and we have successfully authenticated to the lab. So far, we are doing good. Let's jump back over to the lab. Yo, what up, Zach? Had the interview earlier today. Message me on Discord. Even drop it here. Would love to know how it went for you. All right. If you use a profile name, you'll need to add it to your Terraform main file so that Terraform knows which creds to use. So we'll be sure to add that. So building our first AWS resource. You know what I might do if I drop this over here and just throw my terminal over here? I'll zoom out a little bit. Hopefully you guys can still see it. But this might be the easiest way to do this lab. So the first thing we're going to do is make a directory for AWS Workshop. So let's go ahead and do that. We'll do make directory, AWS Workshop, and we'll just CD into it. There we go. And navigate to the directory you just created and create a new file called main.tf. This code below will open Visual Studio Code with a new file. So let's go ahead and do that, main.tf. And we may have to do some things, trust this window. Let's trust it. All right, and we'll add a folder that's also trusted. We'll do home, Cybr, and we'll just select that folder as a trusted folder. But if we jump over to this, we have our main, and we can open up our folder as well. We'll do Tyler, Cybr, Terraform S3, AWS Workshop, and I guess that doesn't really matter. There it is right there. And now we should be good to go. So we have that pulled up, and we will drop that over there. The other thing I like to do is turning on word wrap, and I can also maybe zoom in for you guys a little bit here. Is it? I don't know why it wasn't doing it when I was using the hotkeys, but we'll do it this way. All right, there we go. And Zach said, went super well. It wasn't really asked much technical questions, more so scenario-based. A position will be someone who's going to implement security policy, creating playbooks. Dude, that's awesome. Did they tell you when you're going to hear back from them? All right, anyways, we have created our main. Pro tip, if you don't have the code shortcut set up, you can open Visual Studio Code. Hit Command-Shift-P, search for shell command, install code command and path, and hit enter. What up, Prasajit? Good morning from India. I'm sure I just totally messed up your name, but hey, it's an honor to have you hanging out. All right, we're going to codify an AWS S3 bucket. AWS S3 is a simple resource that enables storing large amounts of data in a cost-effective manner. So like I said, kind of like FTP for the cloud. By default, S3 buckets are private, but can be made public if needed. We'll start by creating a private bucket and then move on to making it public and hosting a static website. Copy the below code into your main.tf file. Let's reference the documentation for the AWS bucket resource here. So we'll go ahead and grab this. And even if you don't know this, it should make a little bit of sense of what we are seeing. Also, do I need to install any extensions for this? I wonder if I do. Let me just check. Let's install this for Terraform to do just some code syntax for us. All right, there we go. Now it looks a little bit nicer. We have some code syntax. We're specifying our provider of AWS. Of course, if we do in Azure, we would do something else. We're doing our region for US East 1. And we do need to do profile lab because I did set up an AWS profile when I did this. If you did not set up an AWS profile, you could leave that commented out. And we are creating a resource. And we're specifying the resource as AWS S3 bucket. And we have to give it a unique bucket name here. But I won't get ahead of us. Let's just keep working through the lab. So you need to uncomment profile lab. Already did that. We'll scroll through. By default, Terraform will look for the AWS creds and AWS creds. If you have multiple profiles, you can specify the profile in the provider block. Otherwise, don't include the profile line. So deploying the Terraform code. Let's work through a few Terraform commands to deploy our code. So do I need to, here, let me go ahead and add a unique bucket name here. We'll do the hack smarter live S3 bucket. All right. I don't think anyone is going to be using that bucket name. Control S to save it. All right, let's work through a few Terraform commands to deploy our code. And what we can do is we can just pull up a terminal here. And I think this will still work. Do lab. And there we go. So we can even run our commands down here as we work through this. So initialize. Terraform init initializes the directory with the necessary plugins and modules. Am I supposed to do that right now? I think so. This creates hidden files and directories within your project directory. So we can go ahead and do this. So we'll type in Terraform initialize. And this is the same way we do Cloud Goat as well. Once we set up Cloud Goat scenarios, we use Terraform for all of that. This creates some hidden files and directories within your project directory. So a .terraform and a .terraform.lock. The .terraform directory contains the plugins and modules that Terraform needs to run, whereas the other file contains the versions of the plugins and modules that were installed. Terraform validate checks the syntax of the code and ensures that the code is valid. It will only check for Terraform-related issues and may not account for AWS-specific issues. And you can see Terraform has been successfully initiated. Beautiful. And we can do Terraform validate. And there we go. It says our configuration is valid. Beautiful. If you have an issue with your code, you'll see an error message here. For example, I've added a fake argument to the AWS S3 bucket resource. Oh, look at that. It's Tyler's bucket. Heck yeah, it's my bucket. That's what I'm talking about. Let's add a false argument here. So we'll say not real equals please subscribe. Right? And now if we save that and we try to Terraform validate, it's going to error out saying that we have an unsupported argument. You can imagine if you're doing a massive file, that's a helpful command you want to run regularly so you don't finish creating the entire file only to have all of it break. And I need a Control S to save it. And now it should validate properly. There we go. Format. Terraform formats the code to ensure it's properly aligned and consistent. If you set up the HashiCorp Terraform plugin for Visual Studio Code, which I did, it will automatically format your code when you save the file. Therefore, you don't need to run this command. Perfect. Plan. Terraform plan shows you what Terraform will do when you run Terraform apply. It will show you the resources that will be created, updated, and destroyed. So let's do that. Terraform plan. And we can see everything that it's doing. Terraform will create the following actions. The AWS S3 bucket will be created. And here's some information. We have the bucket right there, HackSmarter Live S3 bucket, and it provides all the information for us on what it is creating. Terraform apply applies the changes to your infrastructure. This is where Terraform will create the resources you have defined in your code. And let's go ahead and give that a shot. Terraform apply. Fingers crossed. Do you want to perform these actions? Yes, of course I do. Oh no. The specified bucket is not valid. Oh, I just need to try a different name. Okay. Let's try. Here, I'm gonna take Tyler's bucket right here. And we're just gonna do like Tyler's bucket would actually end in 1337. So I'm going to save that up there. And we'll do Terraform init again to initialize it. And then form apply. And yes. There we go. Now I successfully created the bucket. Beautiful. Validating deployment. Once we get confirmation from Terraform that the bucket has been created, we can leverage the AWS CLI to see this. And the way we can do that, just like it shows there, is AWS S3 and then list the buckets. We do need to pass it our profile since we set up a profile called lab, but there we do see our bucket and we were able to do it. Looking over chat, just got in, what lab are you doing? We are doing a completely free lab from Cybr called, jump over to it. If I go over to Learning Paths here, you can make a free account on Cybr and follow along. Otherwise, the standalone video will get posted on my YouTube channel. But on this Learning Path sheet, if Notion would load for us, we're doing this lab right here, creating a static S3 website using Terraform. All right, validating deployment, we did that successfully, and now we are going to create an AWS S3 static website. Now that we have an S3 bucket, let's turn it into a static website. The first thing we need is an HTML file to host. Copy the code below into a file called index.html in the same directory as your main.tf. Replace your name with the name. You know what? We're going to make this a little more special. Let's go to ChatGPT and say, hey, give me the HTML for a static website called Tyler's Hacking Fortress and make it look awesome with a bunch of hacking stuff. Make sure there is a link to my YouTube channel, youtube.com, Tyler, whoops. Let's see how ChatGPT does for us. All right, beautiful, beautiful, beautiful. This is the real way to do this lab. All right, even though we just have an example image, you know what, that'll work. Let's go ahead and grab this, and we will create a new file. It says in the same directory, so we'll create one right here, and we'll just call it index.html, like so. Drop this back over to here, paste it in, and we'll go ahead and save that. Jump back over to lab, and we'll see if this works. So we created it. We need to update our S3 bucket policy to allow anyone to access it. This is controlled via an S3 bucket resource policy. Update your main.tf with the code below. So we'll go ahead and just grab this and we'll look at it once we update it. Oh, we need to just do it with our resource. So we'll copy it from our resource down. So we'll walk through what this is doing. We're passing it our AWS S3 bucket like we did before. You can see it right there, grabbing it from our bucket. But we're giving it public access, right? So it has the effect allow on anyone is able to get the object. So they're able to access our website. I think that code looks good to me. And now we're going to make our bucket accessible. Did we already do that? Oh, wait, hold up. Let's go back. I need to not delete that. Rather, we need to go like this, paste that in there, and then add this one on here. I'll make the bucket public. And we will grab this. There, I think I did that right. We can go ahead and do Terraform. Jeez, I can't type. The Terraform check command. What was that called? Terraform not format, validate. Let's see if my code sucks. What typos do I have? Wow, I don't have any typos. Freaking amazing. Did I make sure I saved it? I didn't break anything in the way I pasted it in. But we should be good. We're doing that, and then we're making our S3 bucket public, adding the public access block so that people are able to access it. Let's scroll down, scroll down, scroll down, enabling the website configuration. Next, we need to upload our HTML file and enable the website configuration on the S3 bucket. This will allow us to host a static website. So you can see kind of what it's doing here. We're going to pass it our index.html, text/html, and then configure the bucket as a website. All of this makes sense. We'll grab this and we'll just keep adding this to our code. Oh, I see. It doesn't like this. Attribute bucket is not specified, and attribute name bucket is required here for Terraform. Let's see. So that's not going to validate, is it? Did I miss something? Here, let me just copy all this. So we have all this, upload HTML to the bucket, configure the bucket as a website. Let me just try to paste that in again. And it still fails. And I bet it won't validate. All right. A block definition must have a block content delimited by that and that, starting on the same line as the block header. So do we just need to put it like that? Hey, look at that. I fixed it myself. Finally, we can add output resource to display the website URL. So let's go ahead and do that. And that's just taking, hey, we want to take the website URL, and when we run this Terraform, it should go ahead and do that. You know what? Here's what I think I'm missing. When I'm copy and pasting, I'm not getting the whole thing. You guys see that? Let's go ahead and do this. Hopefully I didn't break anything by not realizing that ahead of time. It's a downside when you're, oh, it still didn't do it. Does this do it? Geez, okay. I guess I'm going to have to make this full screen. Let's give that a shot now. Oh. No, it's like that. Oh, it's an error on here. You see, I thought I was doing it, but no, it's dropping itself down to website endpoint. That's all supposed to be one line, I am quite certain. Let's go ahead and see if we can fix that. Let's save it, and let's see if Terraform still validates. And it does. Okay, beautiful. We'll scroll back down. And deploying the website, we can do Terraform. We do initialize it first, make sure everything goes through. And now we'll do Terraform apply. Really fingers crossed that this works. Yes. No. Access denied. Oh. Wait. No, that. Does our user try harder? Let's make sure we set up the right profile. And let's make sure our lab didn't expire either. I know I only had 60 minutes. Time left 38 minutes. Our lab hasn't expired. I'm using the lab user. Does my user not have the ability? So our policy operation error, put bucket policy, response error status 403, API error, access denied on line 10. Here's our bucket policy. We're not able to modify that. Is that the issue? What? I didn't do anything different, but maybe I did something wrong the first time I did it, but it worked that time. Let's see if our static website actually works, and I'll even drop it in chat so you guys can check it out. There we go. Amazing. We did it. Let me drop a link. Guys, come check out my static website. Tyler's Hacking Fortress. Welcome to the world of hacking. Hacker image. Here you will find resources, tutorials, and more to sharpen your hacking skills. Dive into the world of cybersecurity, pen testing, and ethical hacking. Loading Tyler's hacking tools, access granted, welcome, and then it goes to my YouTube channel. Amazing. Now I'm curious, what if we play around with this? Right, it's not hacking without some cross-site scripting. We'll just alert 1337. Right, when you load the website, can I save that and just reapply it? All right. I'm guessing it's the same URL, right? Does that not work? Oh, okay. Oh, well. I thought I would try to throw a script in there. Oh, maybe I have to put it in the actual body. Maybe I'm dumb. Here, let's go down to like, we'll throw it in here. And we'll just save. Terraform apply. All right, and let's grab it. Copy. And it still doesn't work. View page source, script. It's not going in there. Is it because it's like cached or something? Does it take a little bit? Maybe it doesn't go through for some reason if I do it in a new browser. No, it doesn't work there either. All right, well, it must be a little bit of time. Oh, you know what I need to do? We have to do Terraform destroy. Yes. Let's destroy it. And now let's do Terraform apply. And then it should add my sweet cross-site scripting in the website. All right, let's see. Haha, there we go. Now I can get you all with my elite hacking skills when you come to my website. We'll pop that 1337 to Tyler's Hacking Fortress. Once again, if you guys want to check it out, there you go. Go check out the website we just spun up using Terraform and an S3 bucket. That's pretty cool. We can close this out. And then that's how we would modify it, right? If we wanted to make changes to it, we would do Terraform destroy and then Terraform apply. And I bet that's what it's going to tell us next. I just got ahead of myself. Deploying the website, navigating to the website, and destroying the infrastructure. When you're done with the infrastructure, you can destroy it using Terraform destroy. It's important to do this to avoid unnecessary costs. For an S3 bucket, you pay for the storage and data transfer costs. See the pricing here for more information. Now, we could actually have a little bit of fun. Make me a static website with something like a hacking to-do list that is vulnerable to cross-site scripting. You guys can go hack yourselves. I'll spin this up and you should be able to execute some cross-site scripting in here. I just want to look at the code on how it does it. Here's our to-do list with some JavaScript here, and we're just accepting user input. We're not sanitizing or validating at all, and then we will go ahead and you should be able to execute some JavaScript in your own browser. Let's paste that in. We will save it. We'll do Terraform destroy. Yes. Terraform, not create, apply, rather. Yes. All right, there's our bucket. My enter key is not working. There we go. All right, into a new task. Hello, subscribers. Oh, it did. Whoops. It didn't even execute. You can see it's trying to. It's actually being commented out. It's not actually executing. We made our thing too safe, but still fun. We could play around with it a little more, but that at least shows the full process. No crypto miners, please. Yeah. We'll drop the crypto miner. Subscribe to Tyler's YouTube channel. And we can even inspect this. We'll go. Can we do some HTML injection? Yeah, so we can do some HTML injection there. Right? So that would be a finding on a pen test. Low, since there's not a whole lot you can do with it, but we at least have HTML injection. H1. Tyler is way too elite. Right? And we could also try something like payloads image. And we'll just grab one of these, like this one. Grab this image source one. And there we go. We have cross-site scripting. Beautiful. So we just had to bypass some protections I accidentally put in place there. But with these, we have cross-site scripting with the image tag. And you can see it there. Those would all be valid findings on a pen test. All of it just starts over if you refresh it. So if you want, I'll drop this link as well. You can go play around and get some cross-site scripting on yourself. Trying to think of anything else fun we could do with our static website before our time runs out. But this is pretty cool. Like, I love how ChatGPT can quickly throw together something like this. If you want to make even your own CTF doing some web app stuff, you can see some ways that you would be able to do that. But here's Tyler's Hacking Fortress with our hacking to-do list. Was a fun lab. Let's go through here and look at our conclusion. Congratulations, you've just used infrastructure as code with Terraform to create and later destroy an Amazon S3 static website. We created it a few times, and if we look over at our code here, we can exit this out. Our main.tf. So remember, our main thing here is in main.tf, we're specifying our AWS provider. We're giving our region and our lab that we want to do these things with. We're creating our S3 bucket profile. We're doing our initial bucket policy here, allowing anyone to do the get object. We're making the publicly accessible on this spot, right? Our public ACL, false, 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 false. So we're not restricting in any way. Then we're uploading our index.html that we created into the bucket to serve as just a static website. We configure the bucket as a website itself, as you can see right here. And then finally, we output the website URL. But this can get a lot more complex. So for example, if we go over to GitHub CloudGoat, I can show you my new scenario that will eventually get approved. It's already done with all the whole process, but this SNS secret scenario, and I mean, you can see all the different changes I made to this scenario. But if we go over to files changed, this is how I created it. So if we look over at like Terraform right here, we can see our output.tf. So very similar to before, we're going to output the information like the access key ID that you start with. We have some provider information here, so similar to what we saw before, specifying the profile and the region from the CloudGoat stuff. But you can kind of read through this and see how I ended up doing it with a lot of banging my head against the wall and ChatGPT's help in order to successfully make this thing actually spin up. So if you run this scenario, it does everything in the background in the AWS account and creates an entire AWS pen testing lab for you to learn how to abuse some SNS secrets type stuff. But that is the fun of Terraform. So I want to say just a huge thank you to Cybr and Christoph in particular. Fun lab. It was fun spinning things up, playing around with it, creating our own little hacking fortress. I am going to destroy that now. So if you guys did not get a chance to look at this, you may want to do that. But let me go ahead and destroy my resource. Terraform destroy. I know I'm not sharing my screen, but you guys saw me do this enough times. There we go. Neffel says, so when you run Terraform destroy, does it remove all the resources created in policies, for example? It does. And that's why with CloudGoat, we use Terraform on the back end, because when you spin up CloudGoat, you're spinning up vulnerable scenarios in your own AWS environment. But when you do destroy, so in CloudGoat, we just made it CloudGoat, which calls Terraform. But when you do CloudGoat destroy, it destroys all the scenario, all the resources, all the policies that spun up. So there's nothing left lingering in your AWS account. So that's how we do it with CloudGoat. And that's a really nice thing about Terraform. Spins them all up and then destroys it. I can even show that to you guys. If you look down right here, once I did Terraform destroy, you can see destroy complete, resources 5 destroyed. So everything it spun up has now been destroyed. But for those of you who did this lab alongside of me, whether you did it live on stream or watching after the fact on YouTube, hey, thank you for taking the time to learn alongside of me, and I will see you in the next one.